Hello again, everyone. Welcome to the part 2 of NeuroSymbolic methods for creative text generation. And in part 1, we saw how we can use common sense knowledge, especially in particular a cause or effect kind of common sense knowledge in order to generate sarcasm. So in the part 2, we'll see about other figurative language generation and how we can also use common sense knowledge to create better figurative language. So the figurative language we're going to talk about in this part is similes. And this is work done and published last year in EMNLP, titled Generating Similes Effortlessly, which can also be written as Generating Similes Like a Pro, a style transfer approach for simile generation. And this is work done in joint collaboration with my PhD advisor, Smaranda Mureshan, and Violet Peng from UCLA. So what is a simile? A simile is a figure of speech that compares two different kinds of things, usually with the intent to make the description more emphatic or vivid. And of course, I cannot go on to give a talk about similes without mentioning one of my favorite similes. So Amy Winehouse in her career best single, Back to Black, said, "And life is like a pipe." So there are several interpretations on the internet. What properties of pipe can map to life? So if you think carefully, a pipe is long, dark, or hollow, and all of these can be inferred using our common sense knowledge. So basically, these properties are mapped to life. So if you see this, life is like a pipe, here there is a structure of the simile, which means that a simile consists of a noun phrase called topic, and then it is compared to another noun phrase called vehicle. So here in particular, life is a topic and a pipe is a vehicle. And these two are compared using a comparator like. Is basically an eventuality or verb. And here the two noun phrases, the topic and the vehicle, are compared to each other, but the property here is implicit, which means it is left to the reader to infer what property of pipe is mapped to life. So this is basically called implicit similes. But it's not necessarily that similes always need to be implicit. It could also be very well written as life is as dark as a pipe. So here, basically, as dark as is basically an comparator. And here we explicitly state the property of darkness to compare life and pipe. So this is an explicit simile. So our task definition is that we focus on the task of generating a simile starting from a literal utterance that contains the topic, the event, and the property. So if you have a literal input, having a thin figure, he looked ugly, our best model generates having a thin figure, he looked like a walking corpse. Similarly, for a literal input, it was obscene, but she was drawn to it, fascinated. Our method generates, it was obscene, but she was drawn to it like a moth to a flame. So we also curiously see, what does GPT-2 say? So we prompt it with the input, it was obscene, but she was drawn to it. And then the GPT-2 model autoregressively completes like a magnet, which is not particularly bad. What happens if we also explicitly prompt with the property? So it was obscene, but she was drawn to it, fascinated. And here GPT-2 says like a bloodhound circling a blood trail, which necessarily doesn't make a lot of sense. Similarly, for having a thin figure, he looked like, when we prompt with this, GPT-2 model says having a thin figure, he looked like a well-built young man. Well, this is definitely contradictory. If you have thin figure, you cannot be well-built. And when we prompt with the property, having a thin figure, he looked ugly, it says having a thin figure, he looked ugly like a volcano. Well, I'm not really sure a thin figure can be compared to a volcano, and also if a volcano is ugly. So as you can see that language models without any sort of common sense knowledge in a zero-shot setting cannot really generate similes. So generating simile is again really challenging. primarily because there is lack of training data that consists of pairs of literal utterances and their equivalent simile in order to train a supervised generative model. And then we also need to ensure that the generated simile makes a meaningful comparison between the topic and the vehicle via the shared property explicitly or implicitly expressed. So in the light of all these challenges, we frame this task as a style transfer problem where the author's intent is to make the description of the topic more emphatic by introducing a comparison with the vehicle via a shared property. So given the lack of training data for simile generation, we propose scope, style transfer through common sense property. And in doing this, we create automatically parallel corpus of literal sentence to simile pairs using common sense property. And then we employ transfer learning from pre-trained model for generating high quality similes. So for parallel data creation, first we crawl self-labeled similes from Reddit. So let's say I'm at work laughing like a crazy person. Now the food I eat tastes like a divine cuisine. It looked like a massacre. It almost sounded like a roar. So we use the heuristic to basically crawl a lot of self-labeled similes from Reddit. Then in the parallel data creation, we convert these to literal sentences using common sense. And how do we go about doing this? So we already talked about COMET, which is a GPT model fine-tuned on ConceptNet, and which is an adaptive knowledge model. So we feed love is like a unicorn, where love is a topic and unicorn is a vehicle. So we take unicorn and then we feed it to Comet, and Comet tells that unicorn has the property of being very rare, beautiful, and smart, and color. So we basically replace unicorn, and we also remove like, and then for the simile, we can create 5 literal sentences. Love is very rare, love is beautiful and smart, and love is color. So then we take these 5 sentences and we re-rank them based on perplexity from a pre-trained GPT model. And then we select the one which is the best perplexity, which means that which would be more human-like. So love is like a unicorn based on perplexity ranking and common sense can be converted to love is rare. And now this basically makes sense because we know that unicorn are rare, and this is the common sense property. So again, as I said, what is Comet? Comet is a transformer-based GPT model fine-tuned on ConceptNet, which can produce common sense knowledge on demand for any head entity that can be expressed through language. So as you see here, if you feed unicorn, then it gives you the following properties. So for parallel data creation, then what we do is we take the self-labeled similes, we feed it to Comet, and then we create the literal output. So I'm at work laughing like a crazy person can be transformed to I'm at work laughing dangerously. Now the food I eat tastes like a divine cuisine can be transformed to now the food I eat tastes delicious. It looked like a massacre can be converted to it looked tragic. It almost sounded like a roar can be converted to it almost sounded loud and powerful. So once we have this weakly supervised parallel data, we fine-tune BART, which is a state-of-art pre-trained sequence-to-sequence model. So here you can see that if we feed the literal input, I wonder hopelessly, to the bidirectional encoder, then the autoregressive decoder generates the simile, I wonder like a lost puppy. So we take the, as again explained, we take the simile and the literal pairs which are created using Comet, and then we feed the literal inputs to the encoder as source, and then the simile as the target to the decoder, and then fine-tune BART, which is a pre-trained sequence-to-sequence model. And then once the model is fine-tuned, what we do is we basically take literal input and then we feed it to the BART, fine-tuned BART model, and then generate the hypothesis using top K sampling. So as you can see here, you just started staring off into space and smiling dangerously. BART generates, you just started staring off into space and smiling like a lunatic. The food cooked by my mother is always delicious. BART transforms this to the food cooked by my mother is always like a feast to me. So as you can see here that BART basically through the fine tuning learns generalization and can then generate novel similes, which it probably didn't see in the training data. So again, we tested on 150 randomly selected literal sentence and compared with gold similes written by literary experts. So the evaluation criteria is automated, human, as well as task-based. There are three types of evaluation involved here. So for automated evaluation, we use Blue 1 and Blue 2, which is n-gram overlap between the reference and the candidate. We also employ BERT score, a similarity score using contextual embeddings between reference and candidate. We also use a novelty metric, that is proportion of generated vehicles conditioned on the literal property that does not appear in the training set. For human evaluation, we rely on the dimensions of creativity, which means how creative are the utterances. Overall quality, which means how good is the simile overall. Third guidelines was to score based on how creative, well-formed, meaningful, and relevant it is with respect to the literal utterance. Then there is relevance 1, which means how relevant is the generated vehicle in terms of portraying the property. And then also relevance 2, which means how relevant is the vehicle to the topic in the generation. So for comparisons, we use different systems. One is a retrieval baseline where we use ConceptNet to retrieve the vehicle using the property. We also use the pre-trained BART to generate the similes. We also use a metaphor masking model where we mask the literal property but keep the context. For example, city was masked and city was like a painting. And then there is scope, which is style transfer through common sense property. And then we also compare this to human written or gold similes. So if you see sample generations by different systems, for the input having a thin figure, he looked ugly, the retrieval baseline says having a thin figure, he looked like a pain. For metaphor masking, it says having a thin figure, he looked like a child. BART says having a thin figure, he looked like a man, while Scope says having a thin figure, he looked like a walking corpse. So the challenge in simile generation is that you not only need to portray the property, but you also need to make sure that the topic and the vehicle are in sync with each other. For example, here, child and man are not necessarily ugly. And then having a thin figure, he looked like a pain. Here, a pain and a thin figure doesn't really make sense. Whereas if you see Scope, a thin figure and walking corpse is something which makes a lot of sense. And walking corpse is also ugly. You could probably imagine that when someone dies, they have kind of become more frail and have a thin figure. And then also something which is a corpse is usually ugly. So this makes a lot more sense than the other examples. So in the auto eval results, we see that in terms of Blue 1 and Blue 2 and BERT score, our Scope model is better than all the baselines. Of course, these results are slightly on the lower end for automatic evaluation metrics because in creative generation tasks, there is no correct answer. So like both the gold and the generated can be correct, but very diverging from each other. In terms of novelty, also, we see that our model does relatively good in terms of novelty, which means that it can still generate novel similes. In terms of human evaluation, we see that the metaphor masking model does decently. Scope beats metaphor masking model in all 4 dimensions. And then retrieval and the BART baseline, even though performing moderately well, are below the Scope model, which shows that our Scope model is better than all baselines. Of course, human 1 and human 2 are better than our best system Scope in terms of like the dimensions of creativity, relevance, and overall quality. But what particularly is encouraging is one of the humans is better and one of the humans is not necessarily better. So if you see that human 2 is actually inferior to our Scope model in a couple of dimensions, which is necessarily encouraging. But I mean, humans also differ in terms of creativity. Not all humans will be very good in terms of writing similes. So for task-based evaluation, we generate 5 sentences stories by fine-tuning GPT-2. And then we rewrite the stories where we replace one random literal sentence ending in an adjective or adverb with a generated simile from 2 best systems. And then we ask Turkers if simile generated by Scope or metaphor masking model make the rewritten stories more creative and evocative. So as you can see here for the prompt of sunset, we generate a story. The sky was beautiful. Jane wanted to see the sunset. She decided to go for a walk. She walked for a long time. When she was done, she saw the sunset was beautiful. So this is a GPT-2 generated story. We randomly select a sentence containing ending in an adjective. For example, here, the sky was beautiful. And then Scope transforms this to the sky was like a blue canvas. So using this approach, we rewrite the stories based on like similes to make it more creative and evocative. And then we compare the original story versus story, which is rewritten using Scope and metaphor masking. Win percentage of each system when compared together, as you can see in this pie chart. 3 systems were presented to the Turkers and asked to choose the best in terms of creativity and evocativeness. Our best model, Scope, wins here by 46.7% times. So clearly that we can see that using these sort of creative generation tasks, the Simile can also improve downstream other generation tasks, such as story generation or poetry generation. So finally, to again summarize what I just talked about, big LMs, even though good at literal text generation, fail to generate creative text rich in imagery or vividness. We propose a theoretically inspired approach and employ common sense knowledge showing how modeling the property correctly leads to better similes. And then our systems outperform existing baseline, but it is still kind of behind human performance. And generating creative and meaningful similes or metaphors open new avenues for digital humanities research. So I guess we have now talked about sarcasm and simile, and you can see how common sense knowledge is kind of ubiquitous and really important for these figurative language generation tasks. And I hope this has given you a lot of interest, and you probably realize why this is hard and important to work on. With that, I would be ending this part, but I would soon be talking about metaphors in the next part. So stay tuned.